do some mechanical ones. Suppose that you were told that y is equal to x squared, and they tell you to find, I don't know, let's see. Alright, to find dy dt when x is equal to, say, 4. Find out what the value of dy dt is when x is 4. So, we're taking the derivative with respect to t. So y equals x squared, that's given. The derivative of y is 1 times this y is in terms of y, and we're asked to find it with respect to t. Okay, I guess we need one more thing. If dx dt is, say, 5. Okay. So the derivative of the right-hand side, derivative of x squared is 2x. X squared is in terms of x, and we're finding the derivative with respect to t. 1 times dy dt is dy dt. And they're telling us x is 4 and dx dt is 5. So x is 4, dx dt is 5. 5 times 2 is 10, times 4 is 40. Try another one like this. These are the 3 mechanical ones. Suppose I tell you that y is equal to x to the 3/2, and I ask you to find dx dt if the y dt is equal to 4 and x is 16. Okay, so we want to find dx dt. That means we have to take the derivative, because that's the only thing that gives things like that, and have dy dt, something that we might want to use. So we know that y is x to the 3 over 2. The derivative of y is 1 times, it's in terms of y, with respect to t. They're telling us to find the derivative of x with respect to t. So when we find the derivative of y, it's also with respect to t. The derivative of the right side, the derivative of x to the 3/2. You bring down the 3/2, you make the new power 1 less. Times x to the 3/2 is in terms of x, the only letter I see, over dt. Now they want us to find dx dt, so we need to solve for this. Well, so you might want to write it this way, 3x to the 1/2 over 2 dx dt. And 1 times dy dt is just dy dt. If the 2's on the bottom, it goes on top. If the 3's on the top and you don't want it, it goes in the bottom. X to the 1/2 on the top, it goes to the bottom. Where on earth am I getting this? Pretty simple. I am multiplying by the reciprocal. I am multiplying by 2 over 3x to the 1/2. That way the 2's go, the 3's cancel, and the x to the 1/2 cancels. So the right hand side is just dx dt, and the left hand side is 2 over 3x to the 1/2 dy dt. And they're asking us to find dx dt. What is dx dt equal? is 16, and dy dt is 4. Well, 4 is on top, 4 goes into 4 one time, and 4 goes into this bottom number 4 times. 2 goes into each of these numbers, 1 in the top, 1 in the bottom, 1 time and 2 times. What survives on top is 1 times 101. What survives in the denominator? 3 times 2, or 6. There's your answer. These are the mechanical problems. That is, there are really no words. For now, let us put words into this. Now, one of the things, maybe this section is harder than I initially said. One of the things you have to know is the formula of different things. You need to know the formula of a square and the formula of a cube, the volume. You need to know the formula for the area of a square and area of a rectangle, the volume of a sphere, the volume of the area of a circle. Okay, so now, how about you have this? You drop a pebble in a lake. How about we say dropping a pebble in a lake causes a ripple effect. A ripple effect. Now, you've all seen that. You drop a pebble in the water, you see a little circle, and a second later it's bigger, and then bigger, and then bigger, and then bigger. Okay, that's called a ripple effect. Okay. Now, notice that each of those circles that I drew, the area is bigger and bigger and bigger. Okay, that is, let me write up the problem. Dropping a pebble in a lake causes a ripple effect. If the radius changes at the rate of 2 inches per second, then find the rate of change of the area of the circle when r is equal to 10 inches. Now, here, at the beginning, the area is 0. A second later, the radius is 2 inches. That is, that length is 2 inches. A second later, it increases another 2 inches. A second later, it increases another 2 inches. So now, the radius is that big. Now, at the beginning, the area was 0. Then you added this amount a second later. And then you added this much more. And then a second later, the radius grew another 2 inches, and you added this much more. Notice that even though the radius is only going up by 2 inches, a constant amount, the change in the area is getting more and more. For example, this change, even though it only grew 2 inches in radius, this change is a lot more than the earlier changes. And the question is, how fast is it changing exactly when the radius is 10 inches? So, the main thing you have to do is come up with an equation, and to come up with the same information like we just did earlier on the mechanical terms. You have a circle. The area of the circle is pi r squared. Okay. Now, it says, if the radius changes, that means the derivative of r. It's changing, it's the derivative. At the rate of 2 inches per second. The change in r is 2 inches, and it's doing it in 1 second. Because the bottom is dt. Instead of saying the change in r over the change in t, we write d instead of their delta or the triangle. The r dt is 2 inches. And then it says, then find the rate of change of the area. So, I meant to write find. Find the a dt when r is 10. When r is 10 inches. Okay. So, this is what we have. So somehow we have, now how do you get dA, d anything? You take the derivative of a, in this case with respect to t. We know a is equal to pi r squared. The derivative of a is 1, which I'm going to ignore, times, it's in terms of a, and we're doing it with respect to t or time. Derivative of the right side. Pi is a constant. If I ask you for the derivative of 7r squared, you'd say 14r. So now you should say 2 pi r times, it's in terms of r, with respect to t. So they asked us, if I'm not mistaken, to find dA dt when r is 10 inches, so r is 10 inches, and the r dt is 2. Okay, 10 inches, and we have 2 inches per second. Well, 2 times 2 is 4, times 10 is 40, times pi is 40 pi, times inch, square inches per second. So dA dt is 40 pi square inches per second. Okay, you're blowing up a balloon. Initially, you blow up the balloon, it doesn't, the volume doesn't seem to grow that much. But later on, it grows at a quicker rate. The question is, what is that rate? Okay, so, alright. You are blowing up a balloon such that the radius is changing. That means derivative. The radius is changing at 3 inches per second. Find the rate of change of the volume when the radius is 20 inches. So you are blowing up a balloon. That means volume. The volume of a balloon is 4/3 pi r cubed. You're blowing up a balloon so that the radius is changing 3 feet per second. 3 inches per second, I meant to say. What's changing 3 inches? The radius, dr. The denominator, 1 second. That's the change in time. The r dt is 3 inches per second. And they want you to find the rate of change of the volume. That means the derivative of the volume. dV dt equals what when the radius is 20 inches. So let's see. They want us to find dV dt. So I take the derivative of both sides with respect to t. V is equal to 4/3 pi r cubed. The derivative of v is 1 times, in terms of v, and we're taking the derivative with respect to t, or time. Now remember, 4/3 pi is a constant. So when you take the derivative, you bring down the 3, and it's going to cancel out with the 3 in the bottom. 4/3 pi times 3, the 3's cancel. That's side work. So we get 4 pi r squared. Now 4/3 pi r cubed, it's in terms of r, and we're finding the derivative with respect to t. And since they asked us for what dV dt is, we don't have to do anything. It already says dV dt equals. It equals this. Hopefully they gave us everything. We all know what 4 is. We know what pi is. R, they had to tell us, it's 20 inches. 20 inches. And the r dt they had to tell us, and they told us it's 3 inches per second. 3 inches per second. All right. 4 times 3 is 12. 12 times 2 is 24. So 12 times 20 is 240. Times pi times inch, which is square inches per second. Now, okay, so I do see your problem. I know that something's wrong because volume is in cubic, in this case, inches. Now, what happened is I wrote down 4, I wrote down pi, I wrote down r, and I wrote down dr dt. But I forgot to square r. It does say square r. It does say to square it. Unfortunately, that's just the last line that has a slight error. Okay, 4. So, right in this corner here, we'll work it out. You have 4 times pi times 20 inches squared times 3 inches. Well, 4 times 3 is 12 times pi times that inch, times 20 squared is 400 times inch squared. Well, 12 times 4 is 48. Don't forget the 2 zeros. Times pi times inch squared, which is inch cubed. And the denominator is seconds. So the final answer is it will increase at the rate of 4,800 pi cubed inches, inch cubed, over second. Every second, the volume will increase by 4,800 pi cubic inches. Volume is in cubic units. Okay, let's try another one. So here's a very classic problem. You have a building, and you have and here's the ground, and you have a ladder resting against the building. The ladder is, say, 25 feet long. The ladder is 25 feet long. Now, somebody, possibly you go to the base of the ladder and you pull it to the right. And we'll call that the x direction and up and down the y direction. You pull it to the right at the rate of 3 feet per second. Now, just because the bottom of the ladder is going along the ground at 3 feet per second, that doesn't mean the top of the ladder is going down at 3 feet per second. It doesn't even mean that it's going down at a constant rate. I mean, basically, on your table, put a book, put your pen or pencil, and try your best to move it to the right. And what you would see is, initially, is going slow. But it's probably around right here. It's just going to take off. Now, what we're asking, this is what we're asking in all the other problems. If you had a radar gun, and you're aiming it right here, right at the tip of the ladder, what would the radar read at some instant? Okay, so the question is, so I told you you're pulling it to the right 3 feet per second. How fast is the top of the ladder falling when the base is the bottom, when the base is exactly 4 feet from the wall. So now when they say how fast, that means what is the rate of the top of the ladder? Well, first, let's try to find some equation. I hope that you see that we have this right triangle. We have this right triangle. This is x, this is y, and the hypotenuse is 25. You need some kind of an equation. Our equation is x squared plus y squared is equal to I meant to call this 5 feet, not 25 feet. Okay, it's 5 feet, sorry. Is equal to 5 squared or 25. Well, how fast is the top of the ladder falling? So they're saying, what is dy dt? What is dy dt? That brought us up to here. When the base is exactly 4 feet from the wall. So x is 4. Here's the wall, and the ladder, the base of the ladder is 4 feet away. At some point, that's going to be 4 feet. Is it always going to be 4 feet? No. But when it is 4 feet, how fast is the ladder falling? And they also told us that the ladder is going to the right, which is a positive amount. So it's positive 3 feet per second. Okay. I suspect I'm going to need the area up here, so let's get rid of it. So I'll continue writing down here, and then I'll go up to the top. So let's take the derivative of the top line with respect to time, that is with respect to t. The derivative of x squared has always been 2x. And x squared is in terms of x, and we're taking the derivative with respect to t. derivative of y squared is 2y. Y squared is in terms of y. We're taking the derivative with respect to t. Equals. The derivative of a constant is 0. So I want to solve for dy dt. So let's solve for this term first by bringing this term to the other side. Now I'm on the top. 2y dy dt is equal to negative 2x dx dt. And then I divide the left side by 2y, and I divide the right side by 2y. Coincidentally, the 2's cancel. So now I know that dy dt is equal to negative x over y dx dt. We're going to come into a little problem, but we'll work it out. There's the negative sign. X is given to be 4 feet. X is 4 feet. We don't know what y will be when x is 4. But we'll find it out in a moment. Times dx dt. Dx dt has been given to be 3 feet per second. Okay, we need to erase the bottom here. So, like I said, we don't know what y is. Now, y is not a constant. For example, okay, so at some point, maybe the ladder, it looks like this. Say initially, the ladder looks like this. Now this distance here, it has to be 5 feet. That's the length of the ladder. The ladder's not changing. You move the base of the ladder to the right, then the ladder falls down a little. So now maybe it's like this. And then sometime later, the ladder to the right, ladder had a fall sign. So all I'm saying is y is not constant. Maybe here it was 10, and then it was 8, and now it's 4. Y is changing. And the ladder's falling down. The distance from the ground, the distance the ladder is from the ground is changing. That's what it means to fall. You drop a ball off the roof of your house, the distance from the ground, the ball is at, it changes. I mean, think about it. At some point, it's going to hit the ground. Right. So this is what. So we're trying to find y when x is 4. So Pythagoras would say, "Oh, I know that answer. The hypotenuse is always 5, the length of the ladder, and x is 4. So what's y? Well, and this is a right triangle. If you were really quick, you would say, oh, that's one of those special triangles, 3, 4, 5. So y is 3. Y is 3. If you're not that quick, you would say, oh, Pythagoras would say x squared plus 4 squared is 5 squared. If I said x squared, I meant to say y squared plus 4 squared equals 5 squared. For 4 squared is 16, and 5 squared is 25. That must be 9. 9 plus 16 is 25. Y squared must be 9, which means y is 3. If y squared is 9, y can be negative 3. Or what would it mean for the length of a triangle? Excuse me. What would it mean for the length of a side of a triangle to be negative inches? Or negative 3 feet. Okay, so y is 3 feet. 3 feet. And actually the 3 feet cancel, and we get negative 4 feet over seconds, per second. Now, we can think about whether or not it makes sense. Why is it negative? Well, I hope that's very obvious. If you're pulling the base of the ladder to the right, then the ladder is falling. It's going down. Negative means down. The change in y is negative. It is decreasing. Okay, so it's going down negative 4 feet per second exactly when it's 4 feet away. Okay. Okay, fine. It is going down 4 feet per second exactly when the ladder is 4 feet from the base, the bottom of the ladder. This right here, the bottom of the ladder, is 4 feet from the wall. This distance should be 4 feet. So again, what's going on is you have this mark here. Somebody has some kind of a radar gun. It's aimed constantly on that point. That point's going to be moving, but it's aimed right at it. And just like the police aim their radar gun at your car, and your car is moving, just like the ladder is, the top of the ladder. And somebody's moving the base of the ladder 3 feet per second to the right, and we want to know how fast the ladder is falling.